guys, today we're going to set up the optics lab. We will be doing the geometrics optics lab with a laser today. So you're going to be finding the manual that says geometric optics lab with laser box. Okay, let me show you the equipment that you're going to need. If I can figure out how to pause. This is going to be tricky because my camera stand broke. But what you're going to need today is you're going to need to find the box that says red diode laser basic optics, and when you open it, it's going to have two things in it. They're going to be wrapped in plastic, probably. That's okay. It's going to have something like this, and then there's going to be a white box, and then the white box is your AC adapter. And this is the first time I've ever seen this, but find the one, obviously, that matches the US sockets. It is cool that they have all the ones there for the international sockets. Super clever. But this is your AC adapter. Now, the laser light's going to be a little easier to use if it's daytime. Now, I'm making this video during the day, and I'm next to a window, and so it's not ideal, but I'll still be able to see my optics if I use a laser, because you can still see that pretty well during sunlight. I do recommend that you do this lab in the dark. The next couple labs are kind of be done in the dark, but science is fun, so let's do that. Okay, let me grab the other piece of equipment. You're gonna need also this pretty thing right here. This came out of a box that is labeled somewhere. Maybe it didn't come out of a labeled box. Maybe it was just in a plastic bag. Anyway, go ahead and unwrap everything here. It says Ray Optics. You're going to have 5 pieces in here. You're going to have this thing. This is just a mirror. It's just got all 3 different types of curved mirror on one side. You're going to have a prism, right? You're going to have this thing. And I'm not 100% sure what this is, other than it can probably be used to create double lens stuff, which is kind of cool. I'll have to play with that. You should have a concave lens that's thinner in the middle and thicker on the edges. And then you should have the convex lens, which is thick in the middle and thin on the edges. So that's what you're going to need for this lab. Right, the objective for this lab is to track the beam of a laser light as it is reflecting, refracting, and diffracting, or dispersing. So as an alternate, you can also use the light source that has 1, 3, or 5 slits instead of the laser, but I'd like for you to use the laser since it is in your kit. If you do want to use the basic light source, you're going to definitely need to be in the dark. But you want to clearly mark the points where the beam has been marked to pass through and indicate the direction of the beam. You're going to write the angles of incidence, reflection, refraction, the refractive index, and you'll complete the results section at the end. So for case A, we're going to be doing a reflection from a plane mirror. I'm going to let you do all the science of it. You don't really need to see what my data looks like, but I am going to show you the equipment. The plane mirror, P-L-A-N-E, is the flat one, the flat side. So you're going to set it up. You're going to plug in your laser, and this is going to be interesting on how we do the laser. You'll just have to hold